So in this question number 9, we have to find the area under this curve. First of all, sketching the curves. So we've got the line y equals 3x plus 12. This time when x equals 0, it cuts at 12, and also the line's increasing from left to right because it's 3x plus 12. And again, we've got a curve y equals x squared plus 2, so it cuts at 2. And to find the area under the curve, we would have to find the area under the line and take away the area under the curve as outlined here. All we've got to do is find the limits, and then we can find the area under the curve. The last part of this particular question asks us to find the volume if the curve is rotated about the x-axis. And the formula for the volume is given by this integral, and if you were asked to do a question on this in the exam, then you'd be given this formula. So the first thing to do is to find the limits a and b, so we can find the area of the curve. And then once we've got that, we can then use those same limits a and b to find the volume of the curve. We would have to find the volume under the line minus the volume under the other line to do it. So let's have a go and see how we get on. So first of all, to find the limits, we set 3x plus 12 equal to x squared plus 2. So for the limits, (3x plus 12) equals x squared plus 2. Making this into a quadratic and then solving the quadratic by factorizing gives us the limits. Very similar to what we had last time. So x equals 5 and minus 2 you should get if you solve that quadratic. So that means the area underneath the curve will equal the integral between minus 2 and 5 of the area under the line, which is 3x plus 12 with respect to x, minus the area between minus 2 and 5 of x squared plus 2 with respect to x. Of course, to speed up this integral, we could combine the two, being careful of signs. So actually, this turns out to be the integral between minus 2 and 5 of 3x plus 12 minus x squared minus 2 dx. Note that because this is minus this, I've got to minus this part and minus that part. And then we can combine that together, collect together any like terms, which might make the integral a bit quicker. So this equals the integral between minus 2 and 5 of minus x squared plus 3x plus 10 with respect to x. So now we can integrate it and put in the limits, and you should get the answer on the sheet. Let's have a look now at the volume part of this function. So for this one, we can see there's the general formula for volume, integral pi y squared dx, rotating about the x-axis. So I'm going to find the volume as the line rotates about the x-axis, and then subtract the volume as the curve rotates about the x-axis. So we just need to square both of these terms, because it's whatever y is squared. So we square out those brackets and then try collecting together like terms, and again we can combine the two integrals. So you could maybe have a go, but the solution follows underneath. Again, we can take the pi outside the integral, so 5 minus 2. Now squaring this, we get 3x times 3x gives us 9x squared. 3x times 12 gives 36x, plus another 3x times 12 gives us 72x, plus 144 with respect to x, minus, again take the pi outside the integral between minus 2 and 5. Now squaring this, we get x to the 4 plus 2x squared plus another 2x squared is 4x squared plus 4 with respect to x. Just check that works by multiplying out those brackets for yourself. Now we could combine these two. So volume equals pi times the integral between minus 2 and 5. Just being careful of the signs. So we've got 9x squared plus 72x plus 144 minus x to the 4 minus 4x squared minus 4 with respect to x. I can combine some of those terms. Minus 2 and 5. So we have a minus 9x squared minus 4x squared is 5x squared. 72x, that's the only term involving x, so that's plus 72x. What about the numbers? We've got 144 minus 4 is 140. And then we've got the minus x to the 4 term with respect to x. So now we perform the integral and put in the limits. See if you can finish that question off now and check that you agree with the answer on the sheet.